Okay, welcome back. When we stopped last time, I had asked you to answer these questions on your own. What are the three types of heating systems? Well, there's forced air, radiator, and electric. Okay, forced air, the air is moved through vents. Okay, it gets hot and convection currents heat the room. It's moved through vent. Radiator, it gets hot and convection currents heat the room. And then electrical, it uses resistance or friction to make metal hot. And then either there could be a fan that's blown with the heater, or it could just use convection currents to move heat around the room. Two ways that solar energy can be used in heating. There's passive, which is just, the way you face the house when you decide to build it. You put windows so the sun shines through on one side of the house. That helps warm it up. Active heating is when you actually installed solar collectors, and that's why it's called active, because you actually built something to go collect the heat. People are using these in all different ways. Sometimes they run them outside to collect heat to heat the home, or like I showed you, to heat hot water. What is a heat engine? Okay, well, it's exactly what its name says, heat to mechanical energy, which is the engine part. So it uses a sort of heat to turn thermal energy into mechanical energy. And we said there were internal and external combustion engines. Internal was when the burning was done inside the power cylinder, and external was when the burning was done outside the power cylinder. And how much of the chemical energy is wasted in an internal combustion engine? We said about 8%. Only about 20% of the engine, only about 20% of the energy that's in the chemical energy is turned into useful chemical energy. Okay, I want to do a quick review of thermal expansion. While we're here, okay, one of the things that happens with heat is as the particles move faster and faster, it causes things to expand. So like when you see sidewalks, they have sheets of cement, and as the particles move faster and faster and faster, they expand. And that's why there's these places here put in on purpose. So as these pieces of cement get bigger or smaller, it doesn't crack the whole sheet. You see these in parking lots and bridges. Okay. In the summertime, this piece of concrete is going to get bigger. It has to have a place to move. So they put this it's called an expansion joint in here, and it'll close up in the summertime, and it'll spread farther apart in the wintertime. And this is another picture of an expansion joint in a sidewalk. As these pieces of concrete heat up, they'll get closer together in the summertime, and they'll get farther apart in the wintertime. Bridges a lot of times have these metal things that look like fingers. In the summer, the bridge will get longer and they'll close up. In the winter, the bridge will get smaller and they'll go farther apart. So it allows the bridge to get longer and shorter as things heat up. And remember, it's caused by the motion of the particles. I want to take a look at this review of thermal expansion and contraction. All right, we're going to take a look at expansion and contraction, which is related to the heat energy of particles in matter. Remember, this goes back to the kinetic energy from the first semester. The faster the particles move, the more heat energy in them, the faster they move. The faster they move, the more they bump into each other. The more they bump into each other, they spread farther apart, causing it to expand. And then the same happens, the opposite happens when you cool them. They move slower, they don't hit each other as hard, and they take up less space, so we call that contraction.
We already know that heating something causes the temperature to rise, but there are other changes that occur in the presence of heat. When most objects are heated, they expand or get bigger, and when they are cooled, they contract or get smaller.
So they're putting this balloon in liquid nitrogen, so it's going to cause the particles to slow down, and we would expect it to contract.
Here is a demonstration of that principle. The metal ball fits easily through the ring. Now the ball is heated for a few minutes. When we try to pull the ball through the ring after heating, it doesn't want to cooperate. If we cool the ball in this water, it contracts and is easily pulled through the ring. You may have noticed that on bridges there is a metal grid at different key points. These
Okay, so as the bridge is heated up in the summertime, okay, the particles do the same thing as that brass knob. Okay, they move faster and faster, and then the bridge expands. As it expands, it gets longer. As it gets longer, these things push together, and that keeps the bridge from breaking itself apart.
gaps are called expansion joints, and they allow for expansion and contraction of the bridge during the summer and winter. Maybe you have noticed that the wires between telephone poles are not pulled tight, but sag. Well, now you know why. The wires must be able to expand or contract depending on the weather. When architects plan and design buildings, they must take expansion and contraction of the materials into consideration.
So these buildings get bigger and smaller depending on the temperature, so they expand and contract. I used to work in an office building like this, and when it got cold, you could actually hear the building kind of creaking as the different things would expand and contract.
So joints are made to be flexible because buildings are expanding and contracting all the time as the seasons change.
We're going to stop there. When we come back next time, we'll be starting a new unit on waves. It was the next form of energy, how energy is transferred. It's transferred in waves. And we're going to be looking at waves in general, and then we're going to study light waves and sound waves more specifically. I hope you're having a great day, and we'll see you next time.